Hi, everyone. A very warm welcome. It's a pleasure to have you all here for this very exciting session. The topic of today's webinar is Exploring the Benefits of 5G Labs for Colleges and Universities. I'm Rohina Chawla, and I'll be moderating today's session. A couple of things before we begin. We'll be recording the webinar and sharing the video with you all to revisit at your convenience and to share ahead. If you have any questions or clarifications during the session, I would request you to please park them in the Q&A section, and we shall take them up in the end. This exclusive webinar is a deep dive into the potential of 5G labs and the transformative impact on educational institutions. 5G labs have emerged as hubs of technological advancement in the education domain, providing students in educational institutions with unparalleled opportunities for learning and innovation. As you all must be aware, our Honorable Prime Minister Shri Narendra Modi ji has launched an initiative to set up 5G labs across different universities and colleges to encourage development of 5G and related technologies and use cases. The initiative is being driven by the Department of Telecommunications, where funding support is being extended to the colleges and universities for setting up such labs. Amantya, a leading indigenous 5G lab solution provider, is actively contributing to fulfilling the Prime Minister's mandate. And we would request all the colleges participating in this webinar to become a part of this initiative and drive India's digital journey. So as we all know, 5G labs create hands-on learning experiences and offer students access to real-world applications that bridge the gap between theoretical learning and practical skills. Furthermore, 5G labs empower educational institutions with the tools to enhance their teaching methodologies and collaborate with industry bodies to co-create exciting 5G use cases, which further help generate new revenue streams for the institutes. Joining us today to share the insights on 5G labs and take us through the demonstration of Amantya's state-of-the-art 5G lab solution are the company's leading 5G experts who bring a wealth of knowledge and expertise in the 5G domain. Gaurav Sharma and Gaurav Saini. I will quickly introduce them before we begin the session. Gaurav Sharma is the AVP Engineering at Amantya Technologies. He has over 2 decades of hands-on experience in the telecom domain and is responsible for managing Amantya's advanced 5G services and solutions portfolio. Gaurav Saini is the AVP Pre-Sales at Amantya. He has comprehensive knowledge of the wireless network market and almost 2 decades of rich industry experience in sales, business development, project management, and customer relationship management. So without any further delay, I will now hand over the floor to Gaurav Saini to give us a brief overview of Amantya Technologies.
Thanks, Rohina, for the introduction. So today's webinar will quickly go over the agenda here. So we'll talk about Amantya as an organization. Then we'll touch base on how the communication in general evolved, starting from 1G and today for moving towards 5G. And then when we talk about 5G lab, what are the basic components somebody can look at when setting up a 5G lab? And also touch base on the benefits of setting up a 5G lab. As Rohina mentioned, our Prime Minister has spoken about widely for setting up 5G labs across India and how 5G labs can benefit everybody in their day-to-day needs, or just not limiting to the basic throughput speeds. Then how Amantya helps and leverages our solutions to set up 5G labs, what are the key differentiators, and what are the use cases in today's market when we talk about 5G labs. Then at last, we'll run through a demo for the complete 5G lab setup we have and how we help institutes, organizations in setting up a 5G lab. Amantya is an Indian organization which has grown rapidly, and today we are 600 plus engineers with our footprint in Gurgaon, Bangalore, and Nagpur, covering entire pan India, which helps us in providing end-to-end support to our customers, institutes, partners. In terms of specific product offering, we do have a large product offering in terms of 5G solution, but today we'll be focusing more on a 5G lab solution offering we have. Amantya, as an indigenous company, has developed a 5G SA core, which is a standalone core, which is fully 3GPP compliant. And when I talk about core, it's both control plane and user plane. Then setting up a lab, we can have multiple deployment model. We do have a network in a box solution, which is a pre-integrated 5G network. And when I talk about network, it has both RAN, core, in a single box along with the ONM. And another deployment model, we have an integrated G-Node B plus core as a distributed deployment model, where we have a core in a single server and multiple RANs can be connected. In both the deployments based on use cases, customer requirements, we do have solution available. As an organization, we have been recognized as a best SME startup in telco at last year at IMC 2022. Then we were preferred workplace in last year. And then we were also featured in ET Telecom, RCR Wireless, and we were marked as a leader in telco domain by Zinnov Zones. So we have been Amantya as an organization doing pretty good and growing at a fast pace in the next generation technology. So today we hear about it was 3G, then 4G, and now it was all talking about, everybody's talking about 5G. So going back long, the first G, which was all analog communication, which started in 1979, it was all one-way radio or one-way communication. When I say one-way, only at a given time, one person was able to talk, another was responding. Then started the second generation, which was GSM, or the 2G phase came in, which started in 1991 and then lasted across 10 to 15 years, where it was all voice communication, and the digital voice started with this 2G. The data rate initially was very low and then gradually upgraded to 144 Mbps, then GPRS, then Edge came in. So the data throughput was still very limited. And 3GPP in 2001 released a standard for 3G, which was basically moving towards a higher data throughputs. With 3G, voice became low priority, slowly and gradually became lower end site of a preference, and data started to gain traction. And then was the major change, where the entire communication architecture became data centric. From our earlier circuit switch networks, everything became packet switch networks. So 4G, which was all data network solutions, started in 2010, where the throughputs of up to 100 to 150 Mbps at 20 megahertz bandwidth started. And then voice with IMS became a network-centric solution. And even today, complete 5G is all data-centric, where the throughput, if I quickly move, where the throughput goes into Gbps. 5G as a standard started in 2019, and now today, all major developing countries have a 5G network setup, and everybody is able to get a throughput of up to 100, 400, 500 Mbps on their handset, which is all on FR1. And when I talk about FR1, FR2 are the basic standards of bandwidth deployments. FR1 is what, sub 6 gigahertz. FR2 is basically 24 gigahertz plus throughput. That's more on the RAN side. But why is 5G being spoken about? We know that from 3G to 4G, we started getting a very good data throughput. 5G is giving us very high throughputs, but that's more for a public user. But when we talk about 5G, there are varied use cases like private 5G networks, low latency networks, along with the gigabit level data speeds. Then when 4G came in, a lot of companies started deploying small IoT devices. When 5G came in for private 5G, the massive device connectivity becomes a crucial part, where thousands of 100K of IoT sensors can be connected in a 1 kilometer square area. That's the enhanced network capacity came in. In the RAN side, if I talk about bandwidth, 4G was limited to 20 megahertz bandwidth. And in 5G, in FR1, we have gone up to 100 megahertz of bandwidth. In FR2, we can go up to 400 megahertz of bandwidth. So the capacity in terms of 5G is massively improved. And there are various other features which we'll talk about across our webinar today. We just spoke about very briefly in terms of 5G capabilities. So, but in terms of setting up 5G lab, like our beloved Prime Minister Modi have said that 5G lab needs to be set up. But why? When we talk about 5G labs, it creates a platform to drive innovation. So when we talk about innovation, 5G, along with this new feature set, which is uh, massive mobile communication, then ultra low latency networks, ultra reliable low latency networks, and then enhanced mobile broadband connectivity. All those three major feature sets for varied use cases can be deployed differently. Each use case could have a different model. This also allows us or everybody to work from an end-to-end communication network. When I say end-to-end, it's more in terms of from a device side, then going to the access network, core network, and then moving towards the application side. Everybody remembers when 3G was there, streaming applications were not there, were very less in numbers. But when 4G started with a HD stream, high HD, and today 4K streaming started. So from a 3G to 4G, the streaming services or high throughput network gained traction. So when now we are moving from 4G to 5G, a lot of new use cases along with high throughput use cases are being spoken about. So when we talk about setting up 5G labs, our two stakeholders are educational institutes and then specifically the students in educational institutes. Let's start with the educational institute in terms of the benefits or 5G lab use cases. So setting up a 5G lab for educational institutes specifically allows them to get into cutting edge technologies. 5G today is moving towards cutting edge technology, and 5G leverages everybody to move into to generate, develop new hardware, new applications, which leverages various feature sets of 5G. So, and then setting up or involving those into their current curriculum is another part of the system. Then education institutes with their 5G lab also enables them to create alliances with startups, where a startup can come in and use their lab to develop some new application, test some applications, test some devices, and in the process help students or help the education institute grow accordingly, learn what industry is moving towards. And then also tying up with various industry leaders for collaborative projects, where you can bring the various large, small startup industries can come in and work in their innovation center and help students and at the same time the industry itself to grow. In the process, the educational institutes will equip the students with hand-on practical training. We know that there are many books and you can talk as much as theoretical knowledge with students, but we understand as a standard practice, you only gain 10% what you read about and you gain 90% what you do hands-on. So once students have a 5G lab and they are able to understand the network architecture, they are able to talk about the device side of the network, they're able to develop some basic application which leverages 5G feature set. All those feature sets helps students in their understanding of 5G network. Now, once you move into the next generation technologies, it could be IoT, drone, various 5G applications like API integration, device side, IoT sensors, which are 5G enabled, or integrating the existing IoT ecosystem with new next generation 5G network. Those all feature sets or the new technology 5G lab can enable students to learn. And then this enables and ignites the creativity and innovation in the students, which helps them learn new use cases or develop new use cases. There could be various use cases which has not been even thought about in a 5G lab, where a student can come in and think a new idea and We can have a totally new use case developed where India could be leading the world. And then setting up a 5G. 5G enables various new generation technologies, and setting up a 5G lab will develop industry relevant skill sets for better employability. So when we talk about 5G lab, 5G access network, and when I talk about 5G access network, it's the radio part of it, basically the G node B in 5G network. That's one. Then 5G core network, which is the brain of 5G network. These two create a complete 5G network. Now, Amantya has a 5G lab radio access network, 5G core network, which is release 16 compliant. Now, on top of that, we also developed sample 5G applications for 5G lab components. So if I specifically talk about the advanced applications, the basic applications like IoT integration, IoT platform, Mac, which has multi-access edge computing. So when we talk about ultra low latency in 5G, Mac, or when in simple terms, edge plays a critical role. Where if you have learned or read about it, that in 5G, carriers and major service providers are setting up edge centers, edge networks. When we talk about edge, it's basically moving all the network compatibility, the network setups at the edge at close as a regional data centers. So when I talk about regional, if I have to access Google, I don't really necessarily have to go to every time from India to US. There could be regional data centers which could leverage, provide me connectivity from me as a user towards going the data packet to a edge center, and then edge center routes it to the localist center if needed. If not, then edge can itself route. This creates a ultra low latency kind of a scenario, or a low provide some very low latency in response. And earlier I spoke about voice calls in 5G or 4G networks. That's where IMS comes into play. Uh, so VoLT or VONR, this is a voice functionality on this 5G network, and IMS plays a critical role. So we have all these functionalities. Now we have a basic functionality. We provide that as a setup of lab. Uh, Now, in terms of providing and building on tops of this, student can create their own application running at the backside, or upgrading these functionalities as and when required by various customers, various partners, or in industry. That enables students to learn about the applications. And on the device side, to set up a 5G network, a handset, which is standard handset, which everybody uses, a smartphone, which can be used for high throughput. Then when we talk about surveillance or five cameras, we know there are Wi-Fi cameras or even wired cameras. But what 5G brings into play is HD or 4K cameras into stream, which is all wireless. You power up a 5G camera and deploy it anywhere. You don't have to think about high coverage of Wi-Fi or a strong wired cabling for setting up 5G camera. Then AR/VR. Setting up a AR/VR requires high throughput and low latency network, be it a gaming, be it learning. That's where 5G comes into play. Then drone setup. Now drone is widely being used, but if you have to provide drone coverage for larger area, that's where you need a good coverage. If you have to stream a 4K video from a drone, a real-time video, then you need a 5G network. Then in IoT kit with a 4K camera or any IoT kit, Amantya has developed basic IoT kits for our setting up in lab, where student can understand how the 5G enabled IoT kits are being streamed. Then 5G CPs as routers, 5G dongles, and evaluation board. When we talk about evaluation board, basically it's a standard 5G kit which has a 5G modem and basic IoT devices or processor, which enables students to develop their own application, their own devices, hardware, and integrate them to a 5G network. So taking any sensor, off-the-shelf sensor, any off-the-shelf device, and connecting it through a 5G network. These all basic kits are part of our 5G lab. This is not a comprehensive list, but these are the major components. And we have various advanced features also, which we can work with institutes in case they are interested. So this is more in terms of setting up a 5G lab. When we talk about 5G lab, in lab we can have network in a box or a 5G network with a kit, with a starter kit, application server, and then the solution comes with a built-in management dashboard and various IoT 5G enabled IoT sensors. We have mentioned few of the standard use cases like smart lighting, environment weather in terms of the IoT end of it. The smart agriculture, which could be smart agriculture when we talk about drones, precision farming, then real-time 4K video monitoring from security perspective, safety perspective, and then 5G enabled sensors over a larger area for water quality measurement. These are some basic use cases. So today, one of the top 5 use cases we speak about, it's education, where when we talk about education, 5G application or prototype development, setting up a complete campus as a 5G enabled. In US or Europe, there are 5G enabled campus which allows students to test their various applications, or even self-driven car vehicles, building complete ecosystem of a self-driving vehicle in their own campus. Then various security, the complete security infrastructure is all 5G enabled. These are various use cases when we talk about 5G enabled campus. Then remote teaching. Everybody saw what happened in COVID, and Wi-Fi played a critical role. However, when we were trying to do our video call on 5G, it was tough. Now that's where 5G is high throughput and reliable network comes into play. And then again with AR, VR, the immersive learning is critical when we talk about 5G network. Now, healthcare is being widely uh, used as a, or 5G is being widely used in healthcare as a use case, where telemedicine with high throughput network, where even in rural, anybody can get a telemedicine using a high throughput 5G network. And then remote surgery, be it AR, VR, or low latency surgery training, remote patient monitoring, which is linked to telemedicine. And then over on top, various IoT sensors are which are being by default enabled with 5G. A patient can wear various sensors for remote monitoring or automated monitoring of a patient. He may be in hospital or he may be anywhere where a real-time data can be passed on to hospital. And even before anything can happen, hospital or doctor can get a report that something is not right and patients can be warned. Agriculture, it's all about precision farming, which reduces the cost of farmers when we talk about monitoring of using a drone or targeted pesticide spraying, targeted weed removal. There are 100 use cases when we talk about agriculture, and 5G is enabling all those. Industry 4.0, that's one of the key pillar of private 5G as a 5G network being deployed. Automation and robotics, then basically improving the capex and opex of an organization. Automation brings a lot of cost saving, enabling their or increasing their productivity. A lot of warehouses are using AGVs, which are all 5G enabled. When we talk about AGVs, it's a larger coverage, larger area they have to cover, and 5G plays a critical role when we talk about mobility over 5G networks. Video surveillance, we have spoken about 5G cameras, asset monitoring, then remote maintenance, various devices and sensors are there for remote monitoring. Smart cities, in the complete self-driving, smart grids, environmental monitoring, and traffic management. 5G is being used or deployed across these use cases for various benefits. So when we talk about Amantya 5G labs, as you notice, we have been working on end-to-end 5G lab. We work from device, then network, and towards the application side. So that's the comprehensive solution enables us to work with institute students to provide an end-to-end 5G network and use case training, deployment, and help them learn more about the system. It's a cost-effective solution because everything is designed in-house. We have already developed 15, deployed all 15 plus labs in colleges across India. And in terms of solution, each institute each deployment could be different, and that's where we have a team which work with the institute and for specific requirements and tailor the solution accordingly. We have multiple deployment scenarios, be it a single box deployment or a distributed architecture, and we offer multiple lab packages, be it basic, intermediate, and advanced. And we also work with students or institutes over the advanced applications or use cases, be it deployment of VONR, MAC, which has multi-access edge computing, enabling AR, VR, video surveillance, AGV apps, and then IoT deploy platforms. Now I'll hand over to my friend Gaurav Sharma to take over from here and talk about our solution offerings in detail.
Yeah, thanks, Gaurav, for that. A very good evening to everybody present on this call. Okay, so now let's jump straight into the technical details of the solution that we have. There are a couple of solutions that we have, especially oriented towards labs. So let me start with the network in a box. Now, this is the simplest and the easiest solution to deploy, instantly giving a 5G network, right? So what this particular box has inside it is a 5G SA core. This is again 3GPP release 16 compliant. There is a 5G NR radio of the G Node B embedded within it as well. We also provide a UPF, which is the user plane function through which the user data passes through the 5G network, plus of course a management interface or a UI to configure this whole solution. Right now, from a lab perspective, why this makes perfect sense is that it abstracts out or it hides the complexity or the technical challenges associated with rolling out a 5G network. Right now, say if I have a lab to put up, right? Of course, I would not want to get bogged down by how do I roll out a 5G network? What is the kind of connections I need to configure? How do I configure the G Node V, etc., etc. Right? So this is a plug and play solution. Right? You just switch it, power it on. We provide a starting configuration, a default starting configuration, which actually suits a lot of scenarios, right? Now, talking about the advantages of this particular solution, as I mentioned, of course, it's comprehensive in the sense it's kind of pre-integrated. Now, apart from these standard 5G nodes or the standard 5G functions, right? There are certain advanced features as well that we've rolled down into this particular solution, right? So one is, of course, integration with MEC, which is for the edge computing. Then you have IMS for VONR calls. And then, of course, we do provide our IoT platform as well as a separate offering. You can hook that IoT platform with this particular solution, and you can go ahead and run various IoT scenarios, develop IoT applications, and then so on. Right now, in terms of band support, it's a pretty flexible solution. So within the FR1 range, you can specify different configurations. Say today, one of the most popular bands, especially in India, that's N77 or N78. We do support that or provide the configurations for that. You can also go into N41. There are other bands as well that is supported. Right now, the advantage of all this is that, say, tomorrow I need to develop an application, right? Or say within one of my colleges or institutes, I want to develop an application and test that how does my application, say, behave in a N41 band, right? I can go ahead and test that. Apart from that, from the management interface as well, and then of course I'll show you some of these things as well as we progress into this meeting. Now, in terms of other configurations for the radio side, you can specify the slot formats, you can specify forms, you can specify MIMO configurations, and so on, right? So tomorrow, if I need to actually see that, okay, in a real life network that has these characteristics, right? How does my application behave, right? Or are there any scenarios that I haven't properly say, investigated, or I want to test them? So this particular solution gives you a very easy way to actually configure this particular box and then start either development or immediate testing of the same. So let me jump to the next slide now. Now, jumping to the next solution. So we can run this particular network in a box in two modes, right? So the previous slide that I showed, if you observed that there was a single core and a single G node B all running within that particular box, and of course the UPF management interface, etc. Right? Now, say as an institute, say I may be needing more G node Bs, right? I have a wider area to cover, or because of some reasons, I want to test my solution across or with multiple G node Bs, right? So what we also offer is another variation of this particular solution, right? So you can get these boxes and run them in a pure G node B mode, right? And then what you can do is the SA core plus the user plane you can run on a separate COTS server. And since the interfaces between these two are standard 3GPP, or we comply to the 3GPP standards, it works perfectly fine. Right now, this is something that we use for a lot of interoperability testing as well. The good part is that there is a single management interface as well. So say I have my multiple G node Bs running, right? And I need to configure some of them. The advantage with this particular solution is you have a single UI. Right? You just open that UI, select the particular G node B, and you can start configuring it. A lot of APIs, or for that matter, a lot of provisioning that we do, that's through netconf. So that gives students a chance to actually understand a lot about the orchestration, the KPIs, alarms, and then features, and so on. And again, within this particular configuration as well, you can run your edge platform, you can run VNR calls, you can test slicing. The core supports 8 slices, right? You can again have the IoT platform running behind this solution. And herein again, you can have different band support, right? Again, sub-6. So one of my G node Bs can be on, say, band 77, the other can be on a different band, and so on. Right. So this is another variation of the solution that we have. And the good part is for specific, especially for institutes, is that even if today they go with the first solution, which is a single box solution, if tomorrow they want to move to this sort of a distributed solution, that's perfectly feasible. That's perfectly possible. You just buy some additional hardware, and we move the SA core to that server. Send you a new G node B box, again pre-configured, and you have your setup up and running. We also provide SIMs, say for your testing purposes, and then you can put these SIMs either in your, say, mobile devices, evaluation boards, or some of the other IoT kits that you might be using, right? So they'll perfectly latch onto our network instantly. Right. So this was more about our distributed core and the RAM solution, right? So this particular slide actually again highlights and captures the differences that I spoke about. You have your single box solution, and then you have an integrated RAN plus core solution where the core UPF runs on a standard COTS server. So again, depending upon the requirements that you have, the kind of capacity that you want from the system, you can choose one of them. And even at a later date, if you want to migrate to say from one solution to another scenario, you can easily do that. Right. Okay. Now let's talk about the demo itself. Right now, I know a lot of you guys would be eager to actually look at the demo, where you'll see the 5G SA core, the G Node V, IoT platform, etc., running. Right. So the demo that we've set up for you is again something which can be very easily replicated in a lab, right? And what we've tried to do today is to give you flavor of the most commonly used functions within a lab, right? So we'll see the SA core, we'll see the G node B, we'll see a couple of other nodes as well. And this will give you some idea that from this solution, right, how you can actually go ahead, write your own applications, experience what is happening within the network, see some of the 5G core messages that are being exchanged, and then so on, right? So it gives you a very first-hand understanding, first-hand experience of the 5G network itself, right? And the way we've structured this whole solution is to abstract out a lot of complexities at the first level, right? So that students or people within the institute, they can focus more on the business logic in the first go. And once they are comfortable with it and may then want to understand 5G technology more, right? I mean, the solution is very open in that sense, right? So you can see the 5G signaling happening. You can see a lot of things being exchanged on the UPF. You can see a lot of G node B stuff that is happening. So from that perspective, it's a very open solution, right? So again, talking about this setup today, so we have a 5G core RAN in a network in a box running. We'll be latching devices on it. We have a 5G camera. We have a 5G IoT kit that has a number of sensors in it, rain sensor, temperature, humidity sensor. Then we've also hooked that up to an IoT platform. I'll also demonstrate the IoT platform that we have. You can actually go ahead and see some of the signaling happening and some of these sensors reporting data to the IoT platform itself. Then we also have a small demo that shows edge computing, right? Now, one of the most interesting use cases or scenarios for 5G is the ability to actually run applications quite close to the G node V or in an environment that is required for latency sensitive applications, right? So you don't have to send the data all through the internet to a remote cloud, but instead of that, you have a edge platform wherein you can run your application, and it gets all the advantages of low latency and edge control. I'll also demonstrate the OAM system that we have. And of course, last but not the least, the VoNR call, right? Mobile network without voice or telephony doesn't make sense. And through this solution, you can actually see your VoNR call also being established, right? So that's one of the primary use cases. We have our IMS solution as well that is integrated within this demo setup as well. So there's a lot of SIP signaling that happens. You should be able to see a glimpse of that as well, right? And you can actually see a VoNR call being executed. Okay, so now let's jump into the video. So that's me, right? And hope you guys enjoy this presentation for this particular demo. And we'll be waiting for your questions after this particular demo is over. Thanks.
Okay, so now let's jump into our lab where we have all these setups ready for you. I mean, the whole idea behind this is to actually show our students and the other faculty members uh, all the action happening in real, right? So what I'll do is I'll take you step by step, one setup at a time, because we have a number of setups out here for you. So we'll start with the first very basic or the initial setup that is related to uh, registering a 5G device into our network, establishing PDU stations for sending, receiving data, right? So let's just immediately jump onto it. So what you see here is our network in a box. Now this particular solution is oriented, as I mentioned earlier, towards universities, colleges, institutes, or even organizations that want to test their 5G devices, right? So what you see inside this box, or what is present inside this box, are in principle a complete 5G network. This consists of your complete 5G G-Node B, CU, RU, plus your 5G core running as well, right? So that's one deployment scenario for this thing. The other thing that you can do is you can continue running your G-Node B inside this particular box, while the 5G core network consisting of AMF, SMF, UPFs, and all the other nodes, you can run that on a separate server as well. The good thing about this solution is that you can use either of the deployment scenarios. Right now, a lot of time what happens, or if you even look at it from a practical perspective, you have a single 5G core that would be supporting hundreds of such G-Node Bs, right? So that's the reason why, in principle, we designed it that way, that you can work with both these modes, right? So as you can see, there are 4 antennas in front of this. So today we are working with a 2x2 MIMO setup. The solution but can be extended to 4x4 MIMOs as well, right? Now let me move to the UI for this particular solution. As you can see, we have a UI that actually demonstrates, or that shows the complete 5G network, right? So you can see the NG RAN, you can see UPF, you can see all these 5G nodes, AMF, SMF, NEF, NRF, PCF, and so on. Now, each of these nodes has a very specific purpose, and all these nodes are compliant to the 3GPP specifications, right? What this UI is also showing is the connectivity between all these different nodes, and the green signal that you see here means that the network is up and running, right? So what we'll do is I'll start with a very basic test case wherein I'll be using my standard 5G Android UE. We'll register this particular UE onto this particular network, and then we'll run some basic YouTube or an application requiring internet access. Okay, so what I've also done is that there's a visor running on this particular 5G Android phone, so that you can see on the screen as well what is happening. So let me just pull that visor up. Okay, so as you see, the UE is in airplane mode at this point of time. So let's just first attach this particular phone to the 5G network. So I've just removed it from the airplane mode, and let's wait for the UE to get registered. Yeah. So as you can see here, I don't know if it's really visible or not, or maybe if you can zoom in. So you can see the device has registered into the 5G network, and I have a 5G icon coming here, right? Now what I can do is, so play one of my favorite live stream, the space station overview camera. Just switch it off. So I'll just skip my ad. And here I go. So this is a live stream from the International Space Station working on 5G. So which means that if I go back to my original UI, so what would be happening at this point of time is that the data from the internet where this particular website is uh, telecasting this particular stream, that would be sending data to my UPF. The UPF would then be sending it to the NGRAN, and the NGRAN is now sending it to our user equipment, right? So that's in principle the simplest thing that we would want to do with a 5G network, right? Yeah, so now let's then jump on to our next setup. Again, one of the most popular 5G use cases, connecting IoT devices, right? Now, the setup that we have today here consists of, again, IoT sensors, wherein we have our rain sensors, humidity, temperature sensors, cameras, again attached to our 5G modem. Now, this again latches onto our network, and then we have our application server with the whole IoT platform that is running. Let me talk a little bit about the IoT platform per se. The IoT platform, what it does is that all the data that is being generated by these sensors, it ingests that data, processes that data, and based on the triggers or rules that we have, it can do certain things. A very simple scenario, say you have a temperature sensor and it senses that the temperature at a particular location exceeds say 30 degrees or whatever that value is. Now that data is related to our uh, IoT platform. You can write triggers that, okay, if the temperature at a particular location is more than a particular threshold, you can then trigger certain actions like starting an air conditioner or starting some cooling device, etc., and so on. So this is a very simple basic use case of our 5G and plus IoT, right? As you can see, yeah, so this is the IoT platform that we have. There are a number of options available here. So entities, devices. So this particular section, this talks more about the sensors that we have in place today. Then you have certain application logic that goes into this particular IoT platform. You can build more complicated application logic on top of it. So this provides basically a framework on top of which you can write your IoT based applications. Again, the data that is coming from the IoT devices, that is coming through the 5G modems, right? So let's take a very simple scenario, and what we'll show today is we have a rain sensor installed here. We'll spray some water on top of it. The rain sensor will sense that, okay, there are water droplets. It'll communicate with the 5G modem. The 5G modem is connected to our network. That will relate this data to the IoT platform, and then you can see certain graphs being or change, some values getting changed in here, right? So let's see that, right? So let me just first show the graph. Rain sensor. So as you can see here, currently there's no rain, right? So let me just take some water and spray it on the sensor. Yeah. So as you can see, the moment I sprayed some water on it, the rain sensor sensed some water and it sent a signal saying that, okay, it is raining or there are water droplets. Immediately, our platform ingested that data, and in this graph, you can see that the value has changed, which is indicating that this particular area has rained, right? Of course, you can write more complicated logic on top of it. So currently, I'm just showing you a graph, but you can write logic that, okay, if it has started to rain, then probably you may want to take an action, send a notification, send a SMS informing people that in a particular location, rain has started. Right? So this was a demonstration of a very simple IoT use case using our network, our IoT platform. Okay, so now let's jump into the third demonstration that we have set up for you guys. This is a demonstration of the edge computing, right? Now, again, from a 5G perspective, one of the most interesting use cases for 5G networks is edge computing. Now, traditionally, a lot of applications that run, they run on the cloud. Now, what 5G has cleverly done is that moved these applications closer to the end user via the 5G edge. Now, what it promises is reduced latency, increased speeds, better customer experience, and it has also led to creation of new applications that are actually only possible for example, car safety applications that are only possible if those applications are actually running on the edge itself, right? So what we will be demonstrating today is our again uh, we have a 5G camera here, right? And what we will be demonstrating today is that the server side of this particular camera, or the stream where this is getting fetched, is running on our edge, and you can actually see the 5G stream at from that application, right? Now, to give you some better idea on how this is happening, is that the application that we have here that talks to our 5G core, it sets up certain special QoS attributes within our UPF to actually support this particular application. And once it has done that, you can then see the video stream happening here, right? So there's a lot of interaction with the NAF, between the NAF, the 5G core, and the UPF. And again, all these are standard 5G call flows. They are very well defined in the 5G standards as well. So all the solutions that you see today, they are 100% compliant to the 3GPP standards, right? So again, 5G camera, 5G modem latched onto our network. The data via the UPF comes to our streaming server, right? So what I'll do is, again, I'll start by clicking on this particular button, and you can see the 5G stream coming in. So this is the stream that is coming. Okay, so now let's jump on to our final demonstration. And what I will be demonstrating today is the VONR call, right? So which is the voice over new radio. Now, one of the principal use cases for any telecommunication network is voice telephony. Again, here 3GPP has taken help of IMS-based networks to provide voice telephony for 5G devices. And what I will be demonstrating today is, again, we have two UEs here, which will latch onto our network. We have our IMS setup also running. The UEs, once they've done the successful registration, they'll be then doing a SIP registration. The context would be set up in the IMS server, and after that I'll make a call from UE A to UE B, and of course there would be some signaling happening in the background and as well, SIP signaling and so on. And once the calls have been established, there would be RTP packets that would be flowing, right? So let's start with first step, that is registering our UEs, right? So herein again, I'll disable the aeroplane mode, and the UEs will latch onto my network. Let me do that. Okay, so as you can see, the UEs have latched onto my network, the 5G network. So the next step, what I'll do is, and again, what you see here is that there are a number of SIP messages that have been exchanged in the background. These are all SIP registrations, and then certain subscriptions that have been created. So now let me jump on to my UEs again. Okay, so now let me call. Again, you can see a lot of SIP signaling happening in the background. So let me just accept this call. Okay. So now both these, so call has been established, a VNR call, and the packets that you see in the background on the Wireshark, these are all RTP, RTCP packets that are being exchanged. So again, the idea here was to demonstrate that how this particular solution supports voice over new radio, not only voice over, but video as well if required. And this is how you can actually see the messages that are exchanged during this whole setup, right? Thank you.
Thank you both for the very interesting and insightful demonstration and discussion. We shall now move on to the Q&A session. You can now share your questions and our panelists will take them up. Okay, I see a fair number of questions already queued in. So let's get started. The first question that I'm taking up is, does your solution support NEF API? Gaurav Sharma, would you like to take that up?
Sure, sure. Yeah, that's a very relevant question to ask, right? Because a lot of these 5G applications and a lot of applications in future, they would rely on the NEF to actually come up with their own application logic, understand what is happening inside the 5G network, what are the various events that are happening within the 5G network, right? So yes, our solution does support NEF. And then let me probably talk a little bit more about this, because I'm sure a lot of students out there who would want to actually develop these applications, they would surely be relying on the NEF APIs to actually write their application logic, right? So I'll just break this into various combinations or groups of the different NEF APIs or functionality, right? So one is, of course, the monitoring group, wherein what NEF provides you is a mechanism wherein you can actually monitor a UE or a group of UEs, right? Now, what does that mean? So things like, when has a subscriber registered, the IP address has been given to him, the PDU session setup, PDU session release, and then so on. So that's the net monitoring part of it. And to talk a little bit more about that, the location or the area that the user is in, right? So that's one group. The other group is the traffic influence, right? So a lot of MEC applications out there wherein you would want to run your application nearer to the G node B or on the edge platform. Therein you would want the user traffic to directly reach to your MEC application, right, or the edge platform. Right? So for that, it's essential to utilize the edge. It's essential to use the traffic influence API. Right? The other group is the setup of additional QoS flows. Now, one of the fundamental features or one advantages of QoS within 5G, and this is where it's very different from 4G as well, is that you can have multiple QoS flows within a particular PDU session, right? Now, what does that mean? So what that means is that you can come up with very specific quality of service characteristics for a particular flow, right? So you can have your flows based on your endpoints or the type of applications and so on. So you can come up with targeted QoS, right? So say, for example, you can provide guaranteed bit rates or maybe have better latencies on that, right? So the QoS flow is another set of APIs that we support today. Now, some of the demos, in fact, or one of the demo that I showed earlier, right, where you saw this edge, the MEC platform being executed, right, the 5G camera application, right. So the architecture behind that is actually utilizing NEF, right. So there are a couple of APIs that the application function of the 5G camera application calls. From the server side, one is, of course, checking it or getting a trigger whenever the UE has registered or 5G camera is registered in the network. That's one. Getting the IP addresses because it has to target the specific nodes. Then it has to set up certain QoS, and then it has to do some traffic influencing as well, right? So utilizing all these different APIs, right? The 5G demo that I showed earlier, right? That's how we actually made that successful, right? Because from an edge application perspective, it's very important to actually execute these APIs, set up the right kind of environment for the application to perform, right? So that's more on the functionality wise. In terms of generic application of F, of course, there are the right security standards that we've implemented. The CAPF interface, because the 3GPP recommends elements of CAPF that go into the NEF implementation. So that's also done. So things like WAF or other sort of things, they're part of the implementation. And it's interesting from the students' perspective as well, right? Wherein they'll actually see that, okay, these are how these things are run in a real environment, right? This is how you consume APIs. This is how you get notifications. This is how, say, IoT platforms may get triggered or IoT applications may get triggered, right? So that's a small description of NEF. Right. Let's jump on to the next question then.
Before I move on to the next question, a small request. I see a lot of raised hands here. Can I request you all to please put your question in the Q&A window? It'll be easier for us to address them then and faster. So I'll get on to the next question. Gaurav, Saini, maybe you could take this up.
Sure.
Okay. Our college has 1,000 square feet area dedicated to such a lab. Which deployment scenario should we consider?
So in terms of deployment scenario, coverage may not be the only factor. 1,000 square feet of coverage area can be provided with a low power solution. Our network in a box or integrated RAN in a plus core, both are suitable for that. More than coverage area, only one setup can provide coverage to the entire 1,000 square feet area. However, in terms of the deployment model, we should focus more on the use case, architecture, or is there any specific requirement in scalability, future scalability, testing use cases. So let me give an example. In case somebody in future wants to have a multiple RAN deployed, or they want to cover multiple labs or multiple rooms with multiple 5G networks, or rather extension of a 5G lab to more coverage areas with more RANs. In that scenario, we should have a integrated RAN plus core in a distributed architecture. In some of the use cases where they're only setting up single 5G labs and one network is suitable for them for future purpose even, then they can even go for network in a box, a one box solution, pre-integrated RAN plus core, a single hardware, and they can go for a single ease of deployment, easy to use network in a box model. So it's more in terms of coverage, it's the use and the future plan which we should consider before for a specific deployment model.
Right now, the next question is, can you trap N1, N2, N3, N4, N6 messages? Gaurav Sharma, could you take this up, please?
Sure. So yes, definitely you can trap those messages. And as I demonstrated earlier, right, it's a very open platform or an open solution that we have out there. You can have your Wireshark or Ethereal or any other tool that's running. And in any case, we also provide the same. So you can actually see the 5G signaling that is happening between the CD device as well as the and the 5G network right now. NGAP or LAS messages, you can hook a Wireshark and see the standard signaling happening between the G node B and the 5G core. Even on the UPF side, I mean, of course, you'll have to actually see that what is the format or the structure of the application data that is going through. You can see that as well, right? And of course, in case if you have security certificates deployed for your end-to-end application, of course, you'll have to take care of that. But otherwise speaking, it's perfectly possible to actually see the real 5G signaling happening between these different nodes and better understand the system in person.
All right. Another question that I'll be taking up is, what about support and training? Do you provide that? Gaurav, Saini, would you answer that, please?
So yes, initially I spoke about our pan-India presence. So we provide support pan-India on pan-India basis. We have offices in Gurgaon, which covers the entire north area. Then Bangalore covers the south, and with the Nagpur office east, and Delhi and Nagpur covers the east and west, the both sides of the geographies. So we have pan-India support. We have a dedicated support team which works with customer. On top of that, we have a dedicated help desk where customers can or institutions can raise tickets. We have a dedicated email ID, a phone number where a ticket can be raised, and based on the priority level, our engineering team or the support team will respond back. Moreover, we have a basic training program or expanded training programs for institutes to provide them training on how to use the 5G network, setting up of 5G labs, and then even after setting up of a lab, we work with our institute partners, customers, to make sure they have hands-on training or all the support is provided as and when required. So we have a comprehensive support team and support plan for all our customers. I hope that answers your question.
Okay, coming to another, maybe just about the last question. Or maybe we can take a couple more. Let's see. Gaurav, Sharma, could you answer this for us, please? Is it possible to customize any ML data science problem using 5G solutions, or should we go with the tools available?
So that's it's perfectly possible to come up with your own ML algorithms and then customize these solutions, right? So you can have your AF running out there. You can build your own logic on top of it, ML logic, and then execute that as well. Right now, one of the things that we are currently also working on is the NWDAF, right? That is the analytics node within the 5G network. So that is something which is in the works right now at this point of time. So what that would actually help you is to actually gather and then process a lot of analytics happening within the 5G network, right? Now, so there are two ways when you talk about this whole ML thing. One is, of course, things that are happening on the NWDAF, and then there are things that are happening on the application function, right? So on the application function, you're free to do whatever you want, build your own ML logic. Based on that, train certain models, execute certain decisions, take certain actions, right? So that's perfectly possible even. So hope that answers your question.
So Gaurav, Saini, next one, maybe you could take. Have you already deployed these labs?
Yes. In India, we have already deployed 15 plus 5G labs in various different deployment models. Some are network in a box, and some are distributed integrated RAN plus core. Some of the labs where we focus on the IoT integration, where we have a comprehensive IoT deployments integrated to 5G network. A few of the labs are more focused toward voice integration, and some of our labs are focused towards API integration and API testing with our customers.
Gaurav, Saini, maybe you could answer this as well. Does it support 4x4, 16x4, 64x4 MIMO?
So So our current solution supports 2x2, 4x for MIMO. Now, when we talk about sub-6 FR1 band, typically 4x for MIMO is easily deployable in the lower frequencies or mid bands. However, if you're talking about 16x16, 64x64 MIMO, that's more FR2 band range, which is like 24 gigahertz to up to 74 gigahertz kind of a band spectrum. Typically, at the moment, even in India, the deployments in mid-band or globally, when I talk about CBRS band, in the mid-band are all deployed. Government has allocated 3.6 gigahertz or even the experimental lab frequencies in mid-band. So typically, 2x2 or 4x4 is widely deployed. We do planning for 16x or 16 or higher MIMO support in our upcoming roadmap features for 5G labs.
Last question that we'll be taking up now. Is there any customization and trade-offs possible with the 5G network? Gaurav, Saini, could you take that up for us again, please?
So when you're talking about customization and trade-offs, so the question mentions 5G network. So if the question specifically is asking about 5G as a technology, 5G, Gaurav Sharma just spoke about NEF, where application integration, customization, and all those flexibilities there. So specifically talking to 5G network as a technology, 3GPP has enabled various customization, various use case enablement, and various, when you talk about trade-offs, it could be good trade-offs specifically to 5G design. So a lot of customization on device side, network side, network slicing, QoS customizations, API integration. So there's thousands of customization features, next generation technology, API integration is available. Now, if the question is more towards 5G lab or our offering, yes, the product we have, the network architecture or the design we have allows various customization. If you have paid attention to the slide deck or what we are talking about, the solution supports various use cases, be it device development or application development. So in the spectrum from end to end, when I talk about end to end device to application, we cover end to end side of a architecture or the deployment model, and the solution support each use case. You can configure the solution accordingly. We support slicing, we support QoS. So when we talk about specific 5G lab solution, we support a lot of use cases. The parameters, the configuration, the deployment model may differ, but the same solution can be used for various different customized use cases.
Right. Thank you so much. Thank you, Gaurav Sharma, Gaurav Saini. It's been a really insightful session. So most of the questions asked here have been addressed, though I do see a few more in the Q&A box. We have noted these and shall be responding to them offline. And we have also recorded the session and will be sharing the video with you all. So with this, we come to the end of today's session on the transformative impact of 5G labs in the education domain and how they empower educational and research institutes to supercharge their capabilities. Thank you everyone for your participation. I hope the session's been helpful for you all. Thank you. Bye-bye.
Thank you.